All right, let's see what we're talking about today and learning about in science. Can somebody read our learning target for Miss Cook? Go ahead, Viv.
Okay. I can identify how a tree traveled halfway across the world by completing an investigation.
Ooh, how a tree traveled halfway across the world? What? Let's see how that is. We're going to start with our activating strategy first. We're going to look at the parts of a plant, or actually, we're going to be looking at pollination. All right, here we go. Come on, vocabulary.
Hey kids, let's talk about plants. Pollination is how plants make seeds that grow into new plants. You see, if you love shrubs, flowers, and trees, you should love pollination. Take it from me. It starts with the flower. Alright, flowers smell nice and they're colored bright. That's to attract birds and bees to help the plant reproduce. Let's see, for each flower, I'll do the explaining. There's two parts, a pistil and a stamen. The stamen has a sticky powder that we call pollen. It's the yellow dust that sometimes starts falling from the trees. It might make you sneeze. Shoo! Well, in order to make seeds, the pollen has to move from the stamen to the pistil. How does it do it? It's not that simple. It's pollination. How plants make seeds, they need to move the pollen just a little, you see. What moves pollen? Birds and bees, or just a little breeze might even lead to pollination. How plants make seeds, they need to move the pollen just a little, you see. What moves pollen? Butterflies and bees, or just a little rain might even lead to pollination. So flowers need pollen to go from the stamen to pistil, and whoa, flowers smell oh so sweet and nice. Plus they're colorful and bright. So believe me, it's easy for birds and bees to find flowers. They want the sweet nectar, see? So some insects and birds have power to buzz and flutter from flower to flower. They carry the pollen on their wings and backs and spread pollen. Why they look for snacks? It doesn't always take animals to move pollen. It can happen when it's windy or rain's falling. Thanks to pollination, the plant has power to grow seeds in the center of the flower. Some flowers grow fruit around the seeds, like a peach, grape, or kiwi. All thanks to pollination. How plants make seeds, they need to move the pollen just a little, you see. What moves pollen? Birds and bees, or just a little breeze might even lead to pollination. How plants make seeds, they need to move the pollen just a little, you see. What moves pollen? Butterflies and bees, or just a little rain might even lead to pollination.
All right, I want you to grab a piece of paper or a whiteboard, a pencil or a marker. And I want you to answer the following question on your paper or on your whiteboard. And the question is, Keelali, make sure your camera is facing the correct way. The question, thank you, Keelali. The question is, how do you think a tree can move halfway across the world? I want you to answer that on your paper or on your whiteboard. Everyone should be answering the question. How do you think a tree can move halfway across the world? All right. I'm going to put you in a breakout room. You're going to share what you wrote on your paper with your partner. Okay. All right. This should take us probably a minute. So we don't have that much time. All right. 3, 4, 5, 6, 2, 4, 6, 8, 10. All right. Go ahead and share. And I'll bring you back to share with me. Everyone should be, you see the, all right. Would someone like to share what they said? Noah, what did you say?
I think they might they might produce more flowers or trees. Like when the bees get the pollen, maybe when they're looking for snacks, I think they travel with the pollen and maybe they accidentally drop some, which causes more to grow.
Oh, I like that observation, Dexter.
Maybe not like the actual tree moved all around, like halfway around the world, but maybe their roots did.
That's a good one, Dexter. Jacoby.
I think when the trees are full grown, they drop seeds so it can spread all over the world.
Okay, Rain.
Okay, so what I said is the birds eat the fruit from the trees, which would most likely have the seeds. And then they would fly halfway across the world, and then they would poop it from the sky.
They would poop the seed out.
Yes.
Okay. I like your observation there. All right. Call on one last friend. Angel, what do you think?
What I'm thinking is getting the seed from a tree,
Mhm.
and then get all the way across across the world, and then plant the seed. Yeah.
And plant. Okay, and plant the seed. All right. Okay, so set your answer to the side. We're going to come back to your answer at the end of today's lesson. Okay, so we're going to see, how did a tree travel halfway around the world?
Hi, it's Jay from the Mystery Science team. This is a koa tree, a kind of tree that grows on the Hawaiian Islands. Koas are impressive to look at. Left undisturbed, koas can grow really tall. They're the tallest native trees in Hawaii.
Evie, we're up here.
Forests filled with koa trees provide homes to many other native Hawaiian plants and animals, like these butterflies, and these colorful birds called Hawaii honeycreepers. And koa trees are colorful on the inside too. Their wood is a beautiful deep red. For thousands of years, Hawaiians have built all kinds of things out of koa wood, from canoes to bowls to ukuleles. Goods made from koa wood are sold around the world. But these days, koas are becoming rare. There are fewer and fewer koas in Hawaii. And for a long time, people thought that this was the only place koa trees naturally grew. But then, a team of scientists made a startling discovery. What they discovered had to do with the kind of tree that grows here, on an island called Reunion. Reunion is halfway across the world from Hawaii. But look at this tree growing on Reunion, and compare it to a koa tree growing in Hawaii. These two trees have the same fluffy flowers. They have the same kind of leaves. And inside, the same dark red wood. After a lot of careful testing, the team confirmed that these trees don't just look the same, they are the same kind of tree. How is this possible? Remember, before this discovery, people thought that the koa only grew in Hawaii, nowhere else in the entire world. How could the same kind of tree show up in two places thousands of miles apart and nowhere else? I wonder if you have any ideas.
All right, let's discuss. How could the same kind of tree grow in only two places, thousands of miles apart? So it's the same tree. It's only in two places, thousands of miles apart. What do you think, London?
I don't think this is the right answer, but I think the roots go under the tank from thousands of miles and go all the way over to and grow it.
Wow. That is a very interesting hypothesis, London. Very interesting. I have never heard that one before, but there's a first for everything. All right, we'll see, London. Keelayli, what you think? Evie, I need you focused.
What I think is that one tree is, why is because one seem, so somebody must have took a seed from the tree and put it on the other side of the world.
Okay, so you think somebody took the seed and brought it over there to the other island, okay, or the other place in the world, okay. All right, that's a good observation or a hypothesis there. Anyone else? I'll take one more friend. Viv.
My mouth was just going all over the place. Because if you look at two other pictures, it kind of looks like the same grass, like the kind of like the same place, but it's not really. But you can kind of see like it's the same grass from the two pictures. And I was also thinking maybe they could have. It could maybe be the same place, but it has a different name and it's in a different other place, but they're still in Hawaii.
Oh, maybe. All right, let's keep going. Good job so far, guys.
Even though trees like these have been growing on Reunion for thousands of years, Scientists think koa have been growing in Hawaii for even longer. So it would make sense if somehow those trees growing on Reunion originally came from Hawaii. Maybe humans took a koa tree from Hawaii to Reunion. That would make sense, right? Humans move all kinds of things. But how could a person get a koa tree from Hawaii to Reunion? I mean, look at this koa tree. It's huge and heavy, not easy to carry. But this tree wasn't always huge and heavy. Like many trees and other plants, each koa tree starts out as a seed. When that seed is in the right conditions, it can start to sprout into a tiny seedling and eventually grow into a tree. That big tree grows seeds of its own. Those seeds drop to the ground where they hopefully sprout and grow into more trees. So all the koa trees in Hawaii and all those matching trees on Reunion started out as the same kind of seed. Seeds are a lot easier for a person to take from place to place than a whole tree. But here's the tricky thing. Scientists think that these trees have been growing on Reunion since long before any human ever set foot there. So it can't have been people that brought koa seeds there. So how else could it have happened? How could a koa seed travel all the way from Hawaii to Reunion?
How could a koa seed travel all the way from Hawaii to Reunion? How can it do that? Evie?
A bee bird or maybe like a butterfly or something could it could fly. Maybe like a butterfly was at Hawaii and it was migrating to a Union.
Okay.
Maybe it's more
what-
there.
Okay. What do you think, Dexter?
Maybe he just like rode on the wind, like in the tiny seed by our crow.
Okay, so you say that one more time, Dexter. You said maybe it what?
Maybe it rode on the wind like from the tiny seed by our crow.
Okay, that could have been a possibility. Angel?
Just kind of wanted to say, at a high level, you're getting the
I
hub
think
done,
that they're going on boats and then they make it.
Oh, I like that one, Angel. I haven't heard that one either. So Angel thinks that maybe the seed got on the boat and then that's how it got to the new location. All right, I have not heard that one either. So London and Angel, today you came up with two things Miss Cook has never heard before, but that is very interesting. All right, let's keep going. You guys are doing awesome. So far today, I've taken points in science from somebody. I've taken 30 points. Make sure you're sitting up and you're paying attention, okay? All right, here we go. Let's go ahead and find out possibly how this seed got to the new location.
To see how a seed might travel all that way, let's look closely at some other kinds of seeds. Take these dandelions. Maybe you've noticed that after they flower, dandelions start to look like these, little fluffy white globes. Each piece of fluff has a seed on the end, right here. Here's an example of a bigger plant. This is a maple tree. Its seeds grow inside this papery, funny-shaped outer covering. The seeds themselves are inside this bump at the end here. What does the shape of these flat papery parts at the end remind you of? Dragonfly wings? Maybe bunny ears? And here's one more. This vine, called a Javan cucumber, grows some really wild-looking seed coverings. Check it out. It almost looks like the seed is inside a clear envelope, an envelope shaped kind of like a boomerang. Now let's take a closer look at some koa seeds. This is what koa seeds look like on their own, and these are what the koa seeds grow inside. Each kind of plant grows its own unique parts in its own unique shape. We call this a plant's structure. Each of the plants we've looked at grows really different structures around their seeds. But all of these seed structures will eventually do the same thing. Drop from the plant they're growing on, travel through the air, and land on the ground. How will the structure around the seeds change how they travel through the air?
All right, so let's think about this. How will the structure around the seeds, so what is surrounding the seed, how is that going to change how they travel through the air? Jacoby?
Probably the weather or something. If it's like really windy, it could blow the seeds.
Okay, so this is the question though. How is what is surrounding the seed? How is that going to change how it travels through the air? So it's going to travel through the air because of the wind, right? But it's going to travel a different type of way because the structure that surrounds the seed, Keelali, is different. So how is the structure going to change how it travels through the air? So look at the way that this seed is inside of this casing, right? Look at the way these seeds are inside of this casing. Which one do you think could possibly travel farthest? Which one do you think could possibly travel farthest? What do you think, Viv? The first or the second?
The first one, because it looks a little lighter.
Okay, that's what I'm thinking. I'm thinking it might be the first one because it looks a little lighter, right? And if I was going to look at this one and this one, have you ever seen these seeds kind of flying off? And have you ever seen that? I've seen that. They're kind of floating by, right? I've seen these falling from the sky, but I don't see them flying by. Do you see them flying by or do you see them falling? I see them falling, right? When Miss Cook was little, we used to call them little helicopters, right? So they would fall down to the, kind of twirl down to the ground, right? So do you see how the structure, the way that the seed is surrounded, it's going to change how it moves through the air, right? All right, does everybody notice that? Everybody understand what Miss Cook is saying? Okay.
In today's activity, you and a partner are going to work together to observe how 3 different types of seeds move through the air: a maple seed, a rain tree seed, and a koa seed. These 3 seeds have very different outer structures, so they're all shaped differently. Your challenge is to discover how a seed structure affects how it travels through the air. Now, we don't have time to travel the world to collect all these seeds today. Instead, you're going to make your own model seeds out of paper. A model is a pretend version of something. Scientists use them to study things that might be hard to get their hands on.
All right, so you are not making a model, but let me see something.
For this,
I would like to see. Let's see.
let's
All right, so this is the maple model, okay? So this is the seed. Do you guys see the seed in her hand? All right, let's see how this seed drops. How does it go to the ground? Does it fly away? Does it just go straight down? Let's take a look to see, okay?
Let's do the first drop test together. Hold your maple model from the side with 2 fingers like this. Reach up with your tree branch arm and hold your model as high as you can. Now,
Before she drops it, how do you think this seed is going to travel? How do you think this seed is going to travel? Put it in the chat box for me. How do you think this seed is going to travel? I should see a response from everyone. I need it. I need you to explain it better. Fall, drop. Okay, we know it's going to come down, but I need you to be more descriptive. Descriptive, 3rd grade. Descriptive. Thank you, Noah. I need description. My big 3rd graders. Keelali, are you going to be the person I'm taking points from next? Looks like it. All right, so London says it's going to fly away. So London is it's going to just fly away like a bird. Which direction, London? I need you to be descriptive. All right, thank you, Dex. That's descriptive. All right, in 5, 4, 3, 2, 1. All right, let's see what happens. And let's see if you're thinking, if your hypothesis is correct.
Open your 2 fingers to drop it from your branch. Observe how your model moves as it falls to the ground. Then, pick it up and test it again. It's important to test your model a few times to see if anything changes. As you do this, talk with your partner about what you notice. I'll set a timer for 3 minutes in case that's helpful. Discuss. How did your maple... Now,
All right,
it's time
so
for
if
you
you
to make
notice,
and test a different...
if you notice, which we
Let's
couldn't
do the
really
first drop.
see because they put a purple barrier there, but what did you notice? How did the maple seed drop, Dex?
It fell down like a helicopter.
It fell down, like Dexter had said in his answer, like a helicopter, right? It didn't fly away like a bird. It fell down like a helicopter. All right, now we're going to look at...
Now, it's time for you to make and test a
another
different model seed. Hold.
Okay,
It's
hold on
time
real
to
quick.
pretend to be a tree again. Stand up and make sure you have enough. Now you have 2 model seed structures
trying
that
to
you can
find.
test. Go ahead and take a seat. Once you're there, discuss. What did you notice about
All
how
right.
your 2 models fell? Did your...
I want you to look at this right here. We have the maple seed and then we have the rain tree seed, okay? I want you to take a look and look at how they are falling. Look at how they are falling, okay? Okay, which one kind of went a little further than the tree? So remember, she's supposed to be the tree. Which one went a little further from the tree? Let me play it one more time. Which one went a little further than the tree? Keelele.
The rain tree.
The rain tree. Does that look like the seed is traveling? Yes. Okay, so it does look like the seed is traveling. All right, I have another one. Let me see. Hold on. 18. Okay, hold on. Let me come over here.
The structures around seeds change how those seeds move through the air. Because each model has a different shape, each one fell in a different way, twirling, coasting sideways, or flip-flopping to the ground. Real seed structures come in different shapes too, and those shapes make them fall in different ways. Check out what the Javan cucumber seed does as it falls.
Do you see
It's
the
like a
seed?
glider. But the structures around these seeds don't just look cool as they coast through the air, they actually give the seeds a better chance at surviving and growing into adult plants. Take this field of dandelions, for example. One dandelion contains hundreds of tiny seeds. If each dandelion in this field dropped hundreds of seeds straight down, there'd be no room for new dandelions to grow. So the seeds have to spread out to survive. Each dandelion seed has its own little parachute of fluff. When a gust of air blows on the dandelion, each tiny fluff parachute carries its seeds far away. When seeds spread out, we say the seeds disperse. When they spread out using the wind, we call that wind dispersal. So if wind dispersal works so well, maybe it was the wind that blew the koa seeds from Hawaii to Reunion. Think about what happened when you dropped your model koa seed. What do you think? Could the wind carry a koa seed halfway across the world? Why or why not?
What do you think? Could the wind carry a koa seed? And here's a picture of the koa seed right here. Could the wind carry a koa seed halfway across the world? Why or why not? Okay, let's see. Viv, what you think?
I think no, because
Okay.
I don't think it'd be able to carry all the way without the koa seed falling to the ground.
Okay. What do you think, Noah?
No, because I don't think it could travel thousands of miles from Hawaii to all the way to Reunion, because it would have to keep traveling without falling in the water or else.
Okay. Or else it'd be pretty wet, right? Let's see. Angel, what you think?
I think Union is too far away for it to make it there.
Okay. It might be too far to make it there. Last friend, London.
The wind. Well, I don't think because it's not gonna happen because I don't think it's gonna stay up for hours. Just for the wind, it's gonna never gonna stay up for hours. Not that long.
Okay, so you say that last part again, London.
I don't think the seed gonna stay up for hours like that because the wind will stop and just go and stop and keep going.
Okay, so London thinks no too. All right, let's see if you guys are correct.
Look at the structure around these koa seeds. They look smooth and long and flat. When we tested our koa seed model, its flat sides did help it tumble and flip-flop as it fell to the ground. But it didn't travel that much. It didn't always drop straight down like a stone, but it still usually landed pretty close. The wind might carry the seed structure a small distance, but could it carry it halfway across the world? Based on our tests, we thought maybe not. In real life, the wind does help koa seeds disperse a little, but scientists don't think the wind alone could carry a koa seed all the way across the ocean. So if koa seeds didn't get from Hawaii to Reunion on the wind, what else could carry them there? Maybe you thought of seeds traveling by water. Hawaii and Reunion are both surrounded by the ocean after all. But salt water can kill most seeds. So seeds that spread out using water usually have a hard, thick outer structure that protects them, like this thick shell. Koa seeds? No thick shell. But check this out. These seeds don't have a hard shell either, but they have something else surrounding them. A juicy fruit. These are cherries. Cherries are tasty, and not just to humans. When you bite into a cherry, you have to be mindful of that hard thing in the center. That thing? It's the seed of a cherry tree. A cherry seed has no special structure to fly. When it falls from a cherry tree, it drops down to the ground like a stone. And it has no hard shell to protect it from water either. So cherry seeds are not wind dispersed, and they're not water dispersed either. So how are cherry seeds dispersed? I wonder if you have any ideas.
How are cherry seeds dispersed? So what could help a cherry seed move from one place to another? What do you think, Keelaylee?
What I think. Okay, so what I think that can help a cherry seed move from one place to another place is I think the seed somebody might pick it up, somebody might take it out of the cherry and put it somewhere else to grow. Another cherry tree.
Okay, what do you think, Andrea?
I think if somebody eats a cherry, then they find the seed and they take it and put it where the garden are, and they put there, and they will let it grow until they become cherries.
So they plant the cherry seed. Is that what you're saying, Andrea?
Uh-huh.
Okay, let's keep going and see.
Think about what an animal like this squirrel would do if she found a tasty cherry. Maybe she'd pick it up in her paws and carry it to a safe place to snack on it. Maybe she'd spit the hard seed out on the ground once she ate the fruit. Maybe she'd even swallow the seed by accident and carry it around in her belly wherever she went next. Animals are another way seeds disperse. When animals eat plant seeds, they can end up carrying those seeds long distances. The structure around koa seeds does help them disperse in the wind, but that same structure also makes these seeds an ideal animal snack. The outer structure is thin and easy to crack into, and inside, koa seeds themselves are small and round, easy for small wildlife near a koa tree to gobble up. Okay, great. So we figured it out. A squirrel ate a koa seed in Hawaii and then got in a hot air balloon and floated all the way to Reunion Island? Wait a minute. That can't be what happened. If an animal dispersed the koa seed, it would have to be some kind of animal that can travel across the ocean to the other side of the world. But what kind of animal can do that? Any ideas?
What kind of animal could carry a koa seed across the ocean to the other side of the world? Tell me in the chat box. What do you think? Oh, a lot of people are saying birds. I see seagull. Oh, a fish. Angel said fish. All right, let's go ahead and find out.
Not many animals can make a journey thousands of miles across the ocean, but these birds can. Scientists now think that this is how koa seeds first got from Hawaii to Reunion. A bird swallowed a koa seed here in Hawaii. That bird took off with the koa seed in its belly. It flew and flew across the ocean until it finally landed here on Reunion. Koa seeds can't fly that far on their own, but because they are so small and snackable, koa seeds don't need tiny papery wings to fly. They can borrow the wings of expert flyers, birds. So next time you spot a seed, whether it's attached to a tree, fallen to the ground, or lodged in the middle of a juicy fruit, take a close look at the structure around it. How would this thing move as it falls? What clues does it give you about how these seeds disperse? Huge plants like koa trees may seem like they've never changed or moved, but sometimes what we see is just one part of a long and epic plant journey. Keep exploring and stay curious.
That was a good lesson, wasn't it? So my question to you, and I'm going to come on back to our slides here. Oops. My question to you was your answer correct from earlier at the beginning of our lesson? The answer that you wrote down on your whiteboard or your paper. So Noah's giving me kinda. Some friends are like, no. Rain, I know you were correct because you did say it out loud. So good job, guys. Awesome. That was fun. I liked that one. All right, we're going to hop right into